So today's lesson is going to be about RxJava and the sort of what I'm going to call this lesson is the observer pattern on steroids. So I had a question from a viewer which was basically, could you explain RxJava? I guess 28 is, I don't know why that seems smaller than usual. Let's go to 30. So I had a viewer ask if I could sort of explain how RxJava works, and as I kind of mentioned in the beginning of this, it's a very difficult topic because it is kind of primarily one concept, which I'll unpack in a moment, but the thing about it is it's more than that. How I would liken it is it's almost like the difference between, say, you have a tool called a saw, and just like a handsaw, and so that thing's called a saw. And then we also have this tool called like a really heavy-duty table saw with attachments and different blades and different things you can do, like a really complicated thing that's a saw. So these things are both saws, but the problem is, you know, one of them is like the simple version and one of them is like the really complicated version. So I wasn't even really planning to use that analogy, but one of my goals in this discussion here is I want to give you a way to think about RxJava. Because what I think I did wrong is I tried to explain RxJava a couple weeks ago by going line by line through the implementation and focusing just on what it does and not so much what it is, which is a tactic I will use when I don't understand something up front. But what I realized is that's not really enough. You do kind of need some help there. So without further ado, let me discuss RxJava. What it is, the bedrock understanding you need to understand what's going on, its features, and there will be some code, and this could be a very long lesson, but hopefully this will be the video or the discussion that helps you understand RxJava. So RxJava, the idea I'm gonna start with is that essentially what RxJava is, and do note that the code samples I'll be showing you are RxJava 2 specifically, but the principles will basically be the same. But essentially what RxJava is it's like the observer pattern on steroids. And what I kind of mean by that is it's just my funny way of basically saying it's like a really high-powered version of the observer pattern, and then there's more to it than that. So that's kind of my first point here, is that ultimately what RxJava is it's sort of an implementation of the observer pattern, which is a well-documented and understood pattern, and you can look this up on your own, and I would suggest that. So I'll give you a quick explanation of how I would explain the observer pattern. Why is it not changing? Maybe I won't. Okay, really? Windows 10. So when I'm zoomed in on an image, I can't change it, but when I zoom out, then I can change it. Great. Awesome user experience, guys. That makes absolute sense. Okay, sorry about that. You knew what to expect when Ryan uses Windows 10 photo viewer. So what is the observer pattern? I didn't plan that, by the way. So what is the observer pattern? And this is the most fundamental thing you need to understand about RxJava. Now, as just a really quick point here, this is the first big difficulty people have, is the jargon. There are two main concepts you need to nail down first, two main definitions. Those definitions, there is an observer, which is something that just watches, sort of like an object or an event stream, and an object or an event stream, essentially what those are is they are subjects. So a subject is something that creates that which, great English there, subject is that, actually no, that is proper English. Subject is that which creates / causes events. So when you look into different implementations of strictly the observer pattern, those are the two main definitions you need to hold in your head. Whether you're looking at RxJava, which uses some different names, or you're looking at some other Rx library, which might use other names, those are the two things you need to nail down. So we have an observer, which is an object that watches something, and we have a subject, which is an object that basically can be watched, can produce events. So I forgot what my next slide is, so hopefully I'll remember what to talk about. Right. So why do we want, what does the observer pattern do for us? What is the difference? So, oh, was I in, sorry, I was in the, let me just go back to that slide really quick. Sorry, I guess I was talking with the full screen view. Anyways, this is the slide. I can share the slides later. So why do we want the observer pattern, and what does it kind of do for us is the next point. So hopefully I've explained to you, RxJava is a way to achieve, it's an implementation of the observer pattern, and what the observer pattern is fundamentally is instead of objects directly sending messages to each other, they can observe each other. They can observe for changes. Now that might not make sense to you right away, so let's keep going, and I think that'll start to make sense as I keep explaining these different slides here. But why do we want objects to just sometimes watch each other, or just sometimes be capable of producing events, instead of every object knowing lots of details about each other? The reason why is it promotes, number one, loose coupling. So what that essentially means is the tethers, the communication tethers between various objects are quite loose, and not like, if we're doing like direct calls between concrete implementations, so my activity directly calls a room database, that's like tight coupling. Like if you change one thing, it's going to change the other. Whereas the observer pattern, you sort of eliminate a lot of that headache simply by way of the pattern itself. When I get to the code, that'll start to make more sense. The other thing is that it allows for many-to-one relationships between subjects and observers. So this is another really key point. So what that means for, this is also, in other words, what I'm saying is this is another factor of loose coupling. When your code is loosely coupled, you can change it. You could add another observer, and that won't change the current observer, and it shouldn't change the subject. So what I'm saying here is you can change things easily because of the observer pattern. It's one of the ways we can really promote loose coupling in our architecture. So hopefully that makes sense. I'm just going to kind of charge along here because otherwise this will take forever. So next slide. So essentially what RxJava is, so hearing that, you might be tempted to think, as I was, that RxJava is just sort of the observer pattern. It's actually a lot more than that. It's almost a bunch of extra tools you get once you start using this sort of observer-subject dynamic. So essentially what RxJava can do is that it allows you to sort of compose and build and create and wire together these observers and subjects. And this is not meant to confuse you, but something can be an observer and a subject. We'll see that later. You can compose these things together as event streams, and that's where the name reactive streams sort of comes from, is once you start to apply this observer pattern, you can almost treat things like as something which either produces an event, relays an event, listens for an event, or changes an event. I'll talk about what an event is in a moment. So let's look at kind of a visual example here of an event stream. I literally made this this morning, so bear with me, as Devore loves it when I say. So What is an event stream? So what I'm going to do now is, so this is, again, one of the main things I think people have difficulty with is they're learning about RxJava and they don't even have a way to think about what's going on. So what I'm going to do now is I'm going to try and explain like a two metaphors for you to understand what an event stream is. So what I've said is RxJava allows you to build an event stream. Well, what is an event stream? Essentially, one example, one of them, I would say the most common example with RxJava is creating an event stream out of, say, something which occurs in the back end. So we could say database, we could say network, we could say system service over here. Some value, some piece of data down here gets created, or an event occurs where this object gets created. So let's say our retrofit adapter calls back with data, or a database returns data. So it creates an event stream where that event starts here in the back end. It'll flow through the architecture. Maybe you should have a boundary between your back end and your front end. And while it's flowing through this event stream, objects can like grab. I want you to think as this ball is rolling or floating down the event stream to get to the front end, the view, we have like the end and then it's flowing. And then say I want to change it part way through, or maybe I want to check this value to see if it was successful or if it needs to be mapped or converted into another object. And then I keep it going down the event stream. And so what that kind of looks like is we get this scenario where our whole architecture, not necessarily the whole, certain parts of it, the asynchronous parts, become streams of events. And then these objects travel through these events when they are triggered, and they change over time if we need them to. And very often we need them to, because a data model that's appropriate for the back end probably won't be appropriate for the front end. So hopefully that's one metaphor. So we're saying we're treating these events that propagate from one class to the other as like an event stream which gets set up. And then while this stream is created, represented by the big arrow, we can send values down the stream. What's a metaphor for this? Because this might still be quite vague for certain people. I'm going to tell you a quick funny story. One of my first jobs when I moved out of home when I was 17 into a big new city was working as a suit salesman in a really old clothing store. This is true. This clothing store was so old that it actually had remnants of a tube system for receipts or bills. So when I never had to do this, but in years past, when a customer bought a piece of clothing, that receipt would get written up, a paper receipt, and then it would get fed into a tube system, which is what you see here, a pneumatic tube system. So how this works is you put the tube, which has like a payload. It's got like a receipt, a little a capsule, not unlike a cup or a plastic tube or a glass tube. So you put the value in it, you put it into the tube, and then it goes boom, and it flies up the tube. Now, what I want you to imagine is, let's say we're running a business, like a big multi-story business, and say we have some department down below, the sales department feeds a tube into, or feeds a value into the tube system. I'm confusing myself because I'll say like a container into the tube system is a better way of putting it. So we feed a container into the tube system, and then let's say it first goes to the accounting department to verify the credit card number or whatever, it doesn't matter. And then eventually it goes to maybe the filing room to store the receipt or something like that. So what I want you to think of is, as a useful metaphor for thinking about RxJava, we're having our objects or the different layers of our architecture communicate through each other by passing these values or what did I call them? Whatever, containers through a tube system, which is like a reactive stream. So hopefully that was a serviceable analogy which can help you start to understand what's going on with RxJava. And I'm going to mention a couple extra things that it does, and then we'll look at some code to cement the metaphor. So kind of my last little slide here is, I mentioned that RxJava is like the observer pattern on steroids. And what I mean by that is you get lots of extra features. It's not just the observer pattern. You can compose multiple streams together. I will show you an example of that shortly. You can change values passed through the stream based on logic. I will show you that shortly. And you can easily manage threading. I will show you that shortly. So there's lots more I could talk about. There's again, like to go back to my original metaphor, one of the problems is if you ask me what a hand saw is, like for cutting wood, if you ask me what a hand saw is, I can explain that to you pretty easily. And then if you ask me what like a complicated multi-tool table saw with all kinds of attachments and so forth is, yeah, I can call it a saw, but that's not really going to give you most of the picture. It's, you know, a lot more complicated than that. So that's basically the theory section of my explanation of RxJava. And the next thing I'll do is I'll take you through some code to sort of demonstrate a couple things I talked about here. And again, my goal is to get you to start thinking of RxJava in your head, not as some magic, not as magic, but really just a communication system, essentially. A really powerful communication system. So I'm going to open up Kotlin Calculator. And link in the description box below if you're curious about this particular, the code in this example. And what we're going to do is we're going to look at, I didn't actually prepare this ahead of time, so you'll have to forgive me. But I'm going to open up a couple of different classes here. All right. And so what we're going to do is what I would like to show you now is an event stream in the code. So everything I just talked about, remember the tube analogy and all that, I want to show you why I chose that analogy and how it actually translates to the code. So what I want you to imagine is, let's say we have like the front end of our architecture. So again, to go back to this little diagram here. So I'm going to show you a presenter, and I want you to kind of just think of that as like the front end. It's the observer at the end. So within Kotlin Calculator, we're going to look at the presenter. And what I want you to notice, so this is a calculator application. And what I want you to notice here is that essentially what I've done is I've represented an event, so like a click event, so when someone hits the equals button, as an event stream, that thing I talked about earlier. So when an event, like a click event, occurs, then what we're going to do is we have this event stream thing, and we execute a call on this thing called a use case. We don't really need to worry too much about that, but essentially we have this object. I won't even use the name. We're going to say to some object, our presenter is going to say to this object, evaluate this expression. So we've got like the start of an event, which is actually occurring synchronously. Notice here we haven't yet returned an observable or anything, but we are calling this method. And what we're doing is we're saying, when we call this method, I want you to actually create like an apparatus around this single method call that can do everything from telling this resulting value, telling the event stream to listen to or telling this particular observer to listen to the value on the UI scheduler, so on a UI thread. And then this is also the place where we say, hey, this is where we actually want to handle the event stream once the event finally reaches its destination. So we're saying, our front end is saying, hey, back end, do this calculation. The back end is like, okay, it does its thing, and then it's sending this object back. Okay, so what is this? So we have our observer here. So presenter is the observer in this case. There's different names, like there's this word subscriber, and there's observable and flowable. I'm not really going to talk about those too much, but what you want to know is this is another word for, say, observer. And that's again where some of the confusion starts. But anyways, I'm not going to get into those kinds of fine details because I actually talked about that in a different video. Okay, so we start our event. We call our evaluator to evaluate an expression. And we've said this is where we want to handle that. Let's hop into evaluate expression. So, excuse me. So our presenter knows almost nothing about this eval object. It doesn't know what it does behind the scenes. All it knows is that when eval does its thing, it's going to return, it's actually going to return essentially a flowable, which is a type of subject? See, this is where the jargon gets insane. Whatever. Anyways, let's just carry on here. So we call this method, and what does this method do? Or what does this method in the use case do? So what I said to myself is, okay, when I'm performing a calculation, I want an object which first checks to see if the expression passed into the calculation is valid. Is it something I can actually feed into a calculator kind of object and actually get something intelligible out of it? So first I validate the input. So what I want you to think of is, okay, so we've got this, as far as the, where's another, just let me show you another diagram. Okay, here we go. So, so what we end up having, essentially what I'm showing you here in Kotlin Calculator. So we have the presenter, which is like the observer or the end point of the stream, where the stream terminates, which is like this thing here. So success, empty, error. And then we have our use case, which talks to like the back end. And what the use case does is it calls two different services. So we have a validator to check if the equation is valid, and we have a calculator to check if the to calculate the equation if it is valid. So what we have essentially is, so this is like the use case I'm showing you, and these are the back-end services. So this is like the validator, and this is like the calculator. Okay, so hopefully that makes sense. So we have like a stream going on here, and the presenter doesn't know about all these different streams and different events that can occur. So hopefully that's kind of making sense. So the last thing I'll kind of talk about here is what happens in this use case. So here is an example where we are we've got an event stream which starts in the presenter, goes to a use case, and then forks into two services. So essentially we have like a many-to-one ratio. And what we can do is, for example, using the RxJava zip operator, we can wait for result of two subjects and compose them together before passing the value through to the observer. Now there's kind of I'm kind of leaving something out, which is that something can actually be both an observer and a subject. So this execute thing here, it is like listening. It is kind of its own observer in a way, but it's also going to produce all of this stuff. When this zip thing happens, the end result of it is we get this thing where our result is like an expression data model. So what I'm showing you here again is this thing. I'm showing you our backend basically has one kind of data model. So here we have this expression object, which is like a backend data model, and we want to sort of make it more appropriate for the view. So essentially what I'm showing you here, you can see this stuff is quite difficult to talk about, but I'm showing you not only are we propagating events from the back end and we're hiding things and composing streams together, but we're changing them over time. So hopefully that kind of makes sense. And the last thing we'll do is I'll show you validation and calculator really quickly. So validation, it just gets given a string, and then the end result is that it produces some kind of value. So it's going to, at this point, as a subject, it will emit, let me zoom way the hell in. As a subject, it will emit a value at the end of this validation. So hopefully that kind of makes sense. And then that's essentially what's going on with the calculator is, again, when it's finished, when calculations are finished, emit the result. And so if we go back to this zip operator, what's happening is we're saying, validator, do your thing and emit the resulting calculation here. And same thing with calculator result. And both of these sort of objects will pop up here in this sort of anonymous kind of method. And this is, of course, the return types that our validator and calculator will actually return. We check first to see if that, first we check to see if it's valid. So if the expression is not valid, we don't even need to care about whether the expression worked. We're just saying create failure model. Something is wrong here. It's not a valid expression. Otherwise, we return a success model. And yeah, and so hopefully that's kind of making sense. So the end result is that to wrap things up, we're starting with an event which occurs in one object. It doesn't necessarily need to propagate through all layers, but it's going to start maybe in one layer or one object, and then it's going to pass down an event stream into the other object. So there's one more point, which is a key point, which I really need to talk about. So number one, you don't need to represent your entire application as event streams. This is one thing. When you're asking yourself, should I use RxJava here, you want to ask the question, is it something that changes over time? Do I need a many-to-one relationship? Do I need to control which thread it's on? And what I'm saying is, when it comes to things in your application which are like totally synchronous, so for example, whenever my view, which is a fragment, talks to the presenter, this doesn't necessarily need to be represented as an event stream. It can be, it totally can be. It's just when you start using RxJava everywhere, you better hope that everyone on your team is on board with that, because you don't actually need, not every event in a system is synchronous. However, most systems do have parts which are asynchronous, and that's kind of my general tip for where you should use RxJava. Anyways, we're almost 40 minutes in here, so I'm really hoping that that explanation helped people. I don't know how well that particularly went, but yeah, that's my lesson on RxJava, and hopefully that was okay.